Hello everyone, Mr. N here again. I'm going to be giving you your next lesson notes on linear equations. So we're going to just talk about a general review of what you guys learned in Algebra 1, except we're going to sum it up in a nice 15-minute video. So here we go. Our lesson is on linear equations. And looking through the individual work I gave you guys, I'm trying to talk about the property of zero a little bit too, so that you can get that question done. So a linear equation. All that a linear equation is an equation that forms a line when it is graphed. Forms a line when graphed. So if you gather a bunch of x's or your inputs, put it in a function, you get a bunch of y's out, or your outputs, you graph them on a coordinate plane and you end up with a line, you've got a linear equation on your hands. So we're going to talk about two specific types for this review. You've probably seen them before. We first have, I'll even color code this, the standard form equation. And so the most general way to look at this is an equation of the form ax plus by equal to c. So this might not seem straightforward, but all this is saying is if you have something in standard form, your x and your y are on the same side and it's set equal to some constant value. So your x's and y are on the same side. An example of this would be negative 6x plus 3y being equal to negative 18. So here notice our value for a is negative 6, b is equal to 3, and c is equal to negative 18. It follows exactly with this form right here. So that's all that we really need to talk about in terms of this, that we can think about the x and y intercepts here if you remember those terms, but usually we're not going to see much in standard form. It's just a way to talk about equations in terms of families and talk about functions in terms of families. What we're really concerned about is slope-intercept form. Slope-intercept form. This is the one you probably remember, the one you will always be using. This has the general form y equals mx plus b. Okay, so turns out we can actually turn this standard form equation into a slope-intercept form. I would encourage you to try it yourself. All you're really doing is solving for the y, so you're going to bring the 6x over to the right by adding 6 to each side, or 6x, and then dividing each side by 3. What you get at the end is y equal to 2x minus 6. So keep in mind our slope now is 2, our y-intercept is equal to negative 6. And it might even be worth it to label these out. So this is our slope, and this is our y-intercept. Okay. So, just as a review, our slope, let's deconstruct this. So, our slope here, m, is going to be the rise over the run. So if we are looking at a value of you can always show this as a whole number as a rational number by putting it over 1. So, next thing we might want to have down is that our b is equal to the y-intercept, or the value of y when x equals 0. So we're going to usually see it on a graph as 0, comma b. So just to kind of put this all into perspective on a nice graph, and then we'll do an example graph with our 2x minus 6. We might have our y-intercept starting down here. So if we're trying to graph based off of our equation, we can identify, okay, well, our b in this example is equal to -6. So we're going to go to this general b value, and then we're looking at a rise over a run to get to our second point. You always need 2 points in order to find your line location and orientation. So maybe we have a run about this far and a rise about this far. Don't worry about the specific values. We're going to get to that with our example at the very end using 2x minus 6. So all there's left to do is connect our 2 lines, and we have our linear equation in the form of a line. So now let's back up a few steps to look at our example. Y equals 2x minus 6. So jump the gun a little bit, but we do have a slope of 2 over 1 and a y-intercept of -6. So it's 1, 2, 3 step process. So the first step we got to do is plot the y-intercept. So I'm taking my graph. Let's see if I can do this nice and neat for you guys. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Downwards, and then 1, 2, 3, 5, 6. So we have to put our intervals nice and neat to make sure we know what our hash marks represent, maybe even label our axes as x and y. So just like up here, we're going to plot the y-intercept first. The b equals -6, so we're down right here. So the next thing we got to do is find our second point so we can figure out the orientation. This -6 kind of gives us where on our y-axis our line is going to cross, but now we need to figure out how steep it is. So that's where we're going to use our our slope. So use slope to find the second point. So a lot of people make a very classic mistake here of thinking, hey, I got my point, now I'm going to start at the origin and use my slope of going over 1 and up 2. But that's not right. We want to start from our y-intercept. So we know that our m is equal to 2 over 1. So all we got to do is step over 1 step and up 2 steps. So we're right up here. So over 1, up 2. So finally, we just connect the dots. So we just draw through right so. And we've got a rough sketch of our linear equation that has a y-intercept at 0, -6, as well as a slope of 2. So my question for you is, well, how would we get a downward sloping line? And I'll leave you with that. Let me know if you have any questions. Oh, right, I was going to actually go over the property of zeros. So let's do that real quick, just so y'all have all the good materials to get this individual work done. So the property of 0. All this property is saying is if you have two values multiplied together and it's equal to 0, you know that it's going to, that one of those things have to be 0. So if, let's use A times B is equal to 0, then one of those two values has to be 0. A has to equal 0, or B has to equal 0. So that's kind of trivial. I mean, of course, you can't really get 0 from multiplication unless one of those numbers are 0, but it becomes actually really helpful when we start thinking about different examples. So I'm going to actually do one of these for you. I think I'll do 113e, so we can get a little bit of review on factoring as well. So 1-13 part E. Okay, so it says to use the property of 0 in order to find the values of x, which make this equation a true statement. So we want to solve for x using property of 0. Okay, so real quick, let's do this. So we have x squared minus 2x minus 35 equal to 0. Okay. First thing we got to do is factor this thing. This might not be familiar to you. I'm going to go ahead and say that the whole point of this is near the end, so I'm going to quickly go over it. So here we want to create a crisscross that we'll actually talk about later on this year, and realize that the value in the middle has to go down below, and the value up top has to go above. So what we want to do is find two values that multiply up to the negative 35, and it adds up to the negative 2. So it turns out that, well, let's try it out. So what numbers multiply up to 35? I do know that, let's see, 7 times 5? Yeah. Negative 7 times 5 is equal to negative 35. So great. Then we know if we add these two together, we get our negative 2. Awesome. So we know that one of these is going to be a negative 7, one of these is going to be a 5. So what we can actually do is factor this like so. So if this step was kind of unfamiliar to you, you're not super comfortable with it, that's totally fine. I want us to be at this point though, and in fact I think it's so important to connect it to up here that I'm going to color code it in the same way. So x minus 7 times x plus 5 is equal to 0. So let's see how our property of 0 can be used here. If this times this is equal to 0, then we know that either a equals 0, x minus 7 equals 0, or the second value, x plus 5, is equal to 0. So it's just simply solving for x. Here we add 7 to both sides, and we know that x can equal 7. In this case, we subtract 5 from both sides. We find that x can also equal negative 5. So for quadratic equations like this, we actually have two different values that can be put into here. So I encourage you to check it out, try to figure out if this actually makes a true statement, or if x equals 7 simplifies to 0 as well as negative 5 to 0, which hint it does. But it's always good to verify this stuff.